last lecture, I explained you the problems based on stream formation. There, we just found out enthalpy. In few problems, they'll ask you if some amount of heat is added, what will happen to the steam, what will happen to the condition of steam. So those kinds of problems we'll solve now. And along with this, we'll solve to find out the specific volume and the internal energy. So in this problem, they asked for a steam initially at 9 bar. They are given the pressure is 9 bar. So that means you should refer to the pressure based steam table. In that you should get all the parameters whatever is required. Then dryness fraction they are given 0.98. So it means that a steam initially at 9 bar and dryness fraction 0.98, it means that it is a wet steam, because dryness fraction 0.98, that means remaining 0.02 is wet. Remaining 0.02 is a wetness fraction. So this is a wet steam. So that is how you identify which type of steam it is. Find the quality and temperature of the steam at each of the following operation. In the first question, when the steam loses 50 kilojoule per kg, what will happen to the condition of steam? That is what the question is. What is the quality? Quality is nothing but dryness fraction. So if it, in this case, there will be some enthalpy. It means that the heat content in this, when the steam initially at this condition, it is having some heat content, that is enthalpy. So at this enthalpy, it is a wet steam because dryness fraction they have given 0.98. If at all it loses this 50 kilojoule per kg, then what will happen to the condition? So what you need to do? Look at this. X they are given 0.98. I have taken it as 0.98. Pressure 9 bar. So I refer to the pressure based steam table. In that I have got TS, HF, HFG, HG, every value I have got. All these values are available in the steam table, and those values I just copied here. Now, what is the initial enthalpy? Initial enthalpy, that is nothing but initial condition. According to this, it is a wet steam. So I use the formula for wet steam. In that, I found out enthalpy. So HF plus X into HFG. Why I use this is, it is because it is having a dryness fraction 0.98. That means it is a wet steam. So I use the formula of enthalpy in the column of wet steam. That is HW is equal to HF plus X into HFG. HF I know, X is the dryness fraction, even that they are given. HFG I have got from the steam table. All the values I just substituted and I got this answer. So this is the initial enthalpy. According to this condition, the initial enthalpy is this. So for this enthalpy, if I subtract this 50 kilojoule, because the steam is losing 50 kilojoule per kg. So for this value, if I subtract 50 kilojoule, what will happen to the condition of steam? So I don't know what is the condition, because if I know it is a wet steam, I'll write as HW. If I know it is a dry steam, I'll mention that it is a HG. If I know that it is a superheated steam, I'll mention that it is H superheated. So since I don't know what is the condition, I simply written H unknown. Obviously, if this is wet steam, if it loses 50 kilojoule, obviously it is a wet steam only. Okay, but still I just written as H unknown. That is equal to HW, that is the initial value, minus 50 kilojoule. When I subtracted 50 to this initial value, I have got this as an answer. Now, what I need to do? I should get to know what is the condition of steam. So what I must do? I'll just compare this with the Hg value. This is the final value I got after subtracting 50 kilojoule. This is the final value I got. This value, if I compare with this Hg, because Hg refers to dry steam. So if this is more than this, then it is a superheated steam. But if this value, the unknown value, is less than this, then it is a wet steam. So this value, it is 2681 and this is 2772. So obviously this value is less than this Hg. So I got to know that this is a wet stream. So H unknown is less than Hg, so it is a wet stream. Final condition wet wet. So I'll mention this as HW. Again, for HW, what is the formula? HF plus X into HFG. HW already got, that is a final value. You already got that value. I'll substitute here because what they asked for, find the quality. You got to know it is a wet stream. It is just a condition. What is a quality? Quality is nothing but if it is a wet stream, you will have to find out X value. Okay. So in this formula, HW is equal to HF plus XHFG. This value I know. This HF and HFG I got from the stream table. Only X is unknown. X, if you find out, that is a quality. So it is not only to find out the condition of stream. Of course, by looking at this, by just comparing this value with this, I got to know it is a wet stream. But that is not the final answer. They asked for quality. So if it is a wet stream, what is the X value? If it is a superheated stream, what is the temperature of superheated? That is a quality. Then in the second question, when the steam receives 150 kilojoule per kg, so what I must do? This is the initial value, no? 2731.6. This is the initial value. If it receives 150, that means for this initial value, I should add 150. So HW plus 150, I have added. For this value, I have added 150 because it is receiving. It has to be added. So 150 I have added. After adding 150, I have got 2881.60. So this is the final enthalpy. After adding 150 kilojoules, this is the final enthalpy. Whenever you add or subtract the enthalpy values, you must check with respect to Hg. Now, 2881 is more than this Hg value. Hg value here is 2772.1. Here you have got the value as 2881. I referred as H unknown because I don't know what is the condition. So I referred as H unknown. If it is wet stream, you write as W. If it is dry stream, you write as G. If it is super stream, you write as you should write as SUP. But since after adding 150 kilojoule, I don't know what is the condition. I'll just check now. I got 2881. This when I compared with this Hg value, I got to know this is more than this. So this is a superrated enthalpy. So in place of unknown, you must write as superrated. Right now, this H unknown value is more than Hg. So unknown is nothing but it is a superrated. I have mentioned as H superrated. You got to know it is a superrated stream. That is a condition you identified. But what they asked for, quality. So quality is nothing but if it is a wet stream, you have to find out X. That is a quality. If it is a superheated stream, you have to find out the temperature of superheated stream. That is a quality. So in this case, you identify that it is a superheated stream. That is a condition. Now you should find out what is the quality. Quality is nothing but temperature. So H superheated, this is a formula you already used, but you already know H superheated value. By adding 150, you got this value. That value directly substitute here. Then in this, you don't know temperature of superheated steam. So you find out what is the temperature of superheated steam. You will get in Kelvin, you convert that into Celsius. That is the final answer. So moving on to next problem. In this, they ask you to find the specific volume and enthalpy of 1 kg. Mass they have given 1 kg at 0.8 megapascal. That is a pressure. Pressure they are given 0.8 megapascal. But in the steam table, we have the pressure in terms of bar. When in the first question, the dryness fraction is 0.9. It means that in the first question, it is a wet steam. In the second question, the steam is superheated. So by that, I'll get to know it is a. So by this, I got to know it is a superheated steam. It is increased up to 300 degrees Celsius. The specific heat of superheated steam they are given as 2.25 kilojoule per kg Kelvin. Okay, remember it is a specific heat of superheated steam, that is CPS. If they give specific heat of water, that is CPW. Okay, moving on to this. Now they have given 0.8 megapascal as the pressure. So at pressure 0.8 megapascal, but in the steam table it is mentioned in bar. So you should convert this megapascal into bar. Simply I followed some steps. If you don't know how to convert this, I just explained here. Zero point 0.8 I kept it as it is into mega is nothing but 10 power 6 pascal is equal to zero point 0.8 into 10 power 6 I converted like this 10 power 1 into 10 power 5. This 10 power 5 is bar. Right now 1 bar is equal to 10 power 5 pascal. So 10 power 5 pascal I mentioned as bar. Then this 0.8 into 10 is 8. So 0.8 into 10 I made as 8. Remaining 10 power 5 pascal I kept it as it is. This 10 power 5 pascal is nothing but it is a bar. So the pressure is 8 bar now. In the steam table you refer based on the pressure, that is at 8 bar you get all these values. Since they ask for specific volume also, you take the Vg value in the steam table, even that is available in the steam table. So since they asked you this, I'm taking this value also along with these values. These values commonly you are taking. Now I have taken this extra because they asked for specific volume also. So now let me take the first question. The dryness fraction they are given 0.9. It means that it is a wet steam. So dryness fraction is nothing but x. X is equal to 0.9. First I need to calculate specific volume. So specific volume for the wet steam, you refer to wet steam formula table. In that specific volume for the wet steam, I have given this x into Vg. X is what? 0.9 they have mentioned. Vg I got from the steam table, that is 0.24026. That value I have substituted here. Directly I'll get this answer. Okay, remember you refer to the wet steam formula table which I have given in the last video. Then along with this you need to find out enthalpy also. So enthalpy again you refer to wet steam formula table. In that HW is equal to HF plus X into HFG. It is a simple formula you already used. HF, HFG both you get from the steam table. X they are given as 0.9. You substitute all the values and you get the answer. That's all. Now in the second question, the steam is superheated to a temperature of 300 degrees Celsius. So in this case, you have to find out specific volume and enthalpy. Okay. So to find out specific volume, again, you refer to the superheated formula table. In that, to find out the specific volume for the superheated steam, I have given this ratio. The ratio between specific volume and the temperature of the superheated steam is equal to the ratio between the specific volume and the temperature of dry steam. So this temperature you already know, that is 300 degrees Celsius. So that is the reason you just have to know this value, this V superheated value. So this temperature of superheated steam, I'll take it to the other side. That way, the specific volume of superheated steam is equal to Vg into T superheated divided by Ts. This Ts where you got from the steam table, that is 170.4 degrees Celsius. But what I mentioned, you always have to keep it in Kelvin. Whenever you are substituting the temperature, you keep it in Kelvin. So the temperature of superheat also, they are given 300 degrees Celsius. But if you convert to Kelvin, it is 573. You just have to add 273. You will get 573. Vg you have got from the steam table again. That value directly substitute. That way you get the specific volume of superheated steam as this. That's all. Then the next one is enthalpy. Again, what is the formula you have to use? Since you know that it is a superheated steam, you refer to the superheated steam, superheated formula table. In that, I have given this formula. H superheated is equal to Hg plus Cps into T superheated minus Ts. All these values you know. Cps they are given 2.25, the specific heat of superheated steam. All the value you just substitute and you get the enthalpy of superheated steam. Thank you.